Thank you very much. So we're going to resume for the second part of today's forum. So this second part is mainly going to focus on the development of secure internet infrastructures. And to do this, we have Chris Abba from AfriNIC, who's with us today. And for moderator, our humble presenter. So we're going to focus on the strength and weaknesses of our infrastructures. And nowadays we're going to see what we can do, what we can improve to have a secure system in place in a world that is more and more attacked. And so security questions are very important. We're now going to give the floor to Brice.
Recording in progress.
His presentation. Hello, everyone. So I'm going to talk about the initiatives for AfriNIC to contribute to the, apologies, I can't hear the speaker properly. So you've got different system, the IRR. We've got different registries in the world. So we have RIPE over here, ARIN for North Africa, LACNIC for Central and South America, APNIC for Asia and Australia, and AfriNIC for us here in Africa and parts of the Indian Ocean. So AfriNIC is the network, the registry for our region, and it covers certain countries. We've got all the different African countries. In Indian Ocean, this was created in 2005. It's a non-lucrative charity-based organization. We've got around 2,130 members who have different services for the community. So what services that our IRRs offer? Well, you've got different services. The main thing is to distribute IP addresses and ASNs. So IPv4 and IPv6 and ASNs. Then second, we've got the coordination of the regional resource policy, the PDWG, the working group. This works for the community and establishes rules that are going to be used by AfriNIC. And we manage local resources. We want to make sure that the resources that we provide our members with in Africa are unique and can be used safely. We've got different things that we can do. We've got services that we provide our members with, the inverted DNS, DNSSEC, IRR, and RPKI. We'll talk to you about these further a bit later on. So AfriNIC as an organization has services that have the RPKI. We also strengthen capacity, provide support, technical support, collaboration, and support programs. We try and work in different countries to organize technical events and regroup experts and trainers. We have a certain collaboration. We work with different organizations in Africa. who work around development of the internet in Africa and beyond. We've got the Internet Society, who we work with, different departments for digital development in Africa, different units, and other organizations like these ones. And we try and support the development of the internet in Africa. AfriNIC communicates with its members and its community via different means. There's a QR code here on the screen. You can copy paste the links on if you're online, or you can also scan the QR code. And this is a whole list, and these are different available resources. I would suggest registering to the announcements. We've got policy discussions. That's a mailing list that is used by the community for coordination around regional policy development. I think it's important to participate because that's the basis for the community. You can learn about such and such measures. We've also got IPv6 in Africa. We've noticed a need for this. We've got many IPv4s, but we need more IPv6s. I think we've got 6 million inhabitants in Congo. And AfriNIC can't even respond to that country's needs, or in Nigeria or South Africa. So this is just to say that IPv6 is needed. And we need this if we want to keep growing the internet. You've also got a list called African. And then African is something where we discuss ICANN in Africa. It's an open discussion on all the problems that people can face with the internet. And the final list is a closed list, the member discussion. It's a listing just for AfriNIC members. If you become a member, you gain access to this. You can register on this mailing list. So just to talk about what we have in Central Africa in terms of resources, in terms of members. So here, you've got ISPs. You've got 57% of members in Africa who are ISPs. Then you have 10% of telecommunication members, 4% of banking and financial members, and 29% of members who are in this category of others. You've got businesses or other members. It's important to realize that you have to be an organization to be a member of AfriNIC, not an individual. So AfriNIC is only open to organizations, businesses. And you have to prove that you interconnect networks in Africa. Then to give you a graph per industry, per sector, so you've got different systems split up, different colors. So nowadays we have a percentage of people, for example, schools who need IP addresses. And we need to host certain servers somewhere and make these IP addresses available to education. So for a couple of years now, we've seen that there's been a lack. And so we've been discussing with the ministry. AfriNIC is very much engaged in government discussions. And we try and discuss all the problems that there are with the internet and how we can best solve them. That's how we manage to overcome certain challenges. So this is to try and see how people can best benefit from all of this. So here, you've got another graph for Central Africa. The largest so over /22, that's 33%. We've got few operators who have a large blocks of prefixes. You've got then the /19. In other regions, you've got different blocks. For IPv6, you've got some who've got a /32. So again, you can see that the internet service providers have the most. They're the largest part of companies who use IPv6. If you ask AfriNIC and you get these types of blocks, it can be quite useful. So when it comes to the ASNs, you've got a similar split. You've got different members, and the internet service provider is again the most prevalent one. So there's a total 111 ASNs who have been provided to these different industries. So as you can see, regulators, governments see more and more countries who realize the importance of these. And regulators use specific addresses for governments. So we've got address blocks for different services. Can you hear me? Is it any better?
It's a bit like there's a print. Still sound a bit like there's a printer in the background.
Yeah, is he asking me the question? Sorry.
I think he's asking if it's okay for the interpreters and still crackling.
Is it any better? On the interpreter side, we can still very much hear the crackling noise. So for IXPs in Central Africa, we have 8 IXPs and 82 interconnected peering. We've got over 2,000 peerings in place on these different IXPs. So this morning, I was talking about the advantages linked to the use of the internet and IXPs and the reduction of fees and subscriptions. And this morning, we also mentioned the reduction of costs for the internet, especially internationally, because the international transit is reduced. And because it's local, you've got different stakeholders, politicians who can, and policies who can work closely with reality. They can develop actual policies that make a real difference rather than policies that are implemented internationally. So there's more benefits. I think it can help for people who want to see the benefits. So this helps in the creation of initiatives and different people who work in the internet sector in Africa. So now we're going to discuss routing security. We understand that the internet wasn't secure because we weren't going to have the same use as we have today.
So we're now going to talk about securing routing and what strategies can be used to secure routing in the African region. So we are able to validate origin using the BGP protocol, but there's no security protocol built in. At least it wasn't implemented in the protocol. We found ourselves in a situation when MTN has made it possible to announce a prefix and so on and so forth. To avoid this, we have worked at ensuring that whoever is announcing the prefix is indeed the owner of the prefix. And that's done through an origin validation strategy. What was adopted to do so is the IRR/RPKI, and AfriNIC has implemented this approach to support the African community to secure routing, internet routing. So this registry, this IRR, is also very important, of course, and it's based on a routing protocol for each ASN. And each ASN presents how they want access to their network to work. It's the routing policies, if you want. And it's materialized by the routes object, specific objects that exist in the different routing systems. And you've got the ASN, and it's there to protect the inside mechanism so that a company cannot create a routing object instead of another company. So it's a verification mechanism to ensure origin. NTN cannot, for instance, use the prefix of another company. So this mechanism checks that whichever object is created does indeed come from the person or company that claims to be at the origin of it. These objects are accessible to the public through the link that you can see on the screen, and you can also check the AfriNIC database to identify these routing objects and see where they're from. And you've got the routing policies and it's making it easier to track the policies, the routing policies in Africa. This register is important. As I said, it enables you to ensure that, for instance, MTM is indeed the owner of the IP addresses that they announce, because it's entitled to create this system, because that's what's built into AfriNIC and it's verified. It also ensures coherence and stability of a global system, because nowadays most providers don't do manual announcements. So, for instance, if you reach out to an internet service provider, you've got your block address, it's not going to ask you to manually verify. It's going to ask if the routing is, the routing structures are in place and verified. And it's automatically created. It also important for stability and coherence, because it enables automatic filtering, depending on routers used, etc. It's done automatically now. It's easier to handle. It's more flexible compared to the manual model we had in the past. So this is a database routing structure. As you can see, most RIRs have got their own routing register. And what's most important here is that these routing risks are interconnected. So if you've got your routing policy from RADB, you don't need to create another one in AfriNIC or another one. They're all interconnected, these registers. And that's why, as I said, you have an object verified for routing in one of these databases. You don't need to recreate this object in another routing table. Here we're looking at what's used within our routing policy. These are objects related to AfriNIC. That's our example, of course. You see all these objects on the screen. You've got role objects, that you've got ITNUM that am I highlighting on the screen. So there's specific data connected to each with specific IP addresses, information specific to users. All these objects are then protected by a security object, the mTenor, which role it is to secure these other objects. So it's got built-in mechanisms for that. And that's how it works. And so you've got the location objects and the routing, the allocation objects and the routing objects. And you've got the IPv6 and IPv4 addresses that you can see separated on the screen. So you've got the routing object in the center. Sorry, on the right. So these are the routing objects just circled on the screen. So a bit of historical background. AfriNIC rolled out the IRR roughly since 2013. And from 2018, we had a number of members who had resources that have come from European countries. And some members had created routing objects. And at one point, we had to ask our members to repatriate routing objects. And it's been done. It's been an ongoing process. And I think over 98% of our members have their own routing objects within their routing policy within AfriNIC. So I mentioned the previous points. As I said, what's interesting here is that the routing risk is not enough to optimize fully security, and that's why you need to ask resource public key infrastructures, the RPKI, sorry. And it's when you've got a third-party validation, and this is the type of infrastructure you've got within an RPKI model. So our members are represented here. So you've got the edge router, then there's a validator, which is in fact a server that validates and ensures that the resources or the routing object received does indeed belong to who it claims to be, the official owner. And that's done through a register that's also been developed by AfriNIC with validation models, which we'll come back to. And then there's statuses. So a prefix is either valid or invalid, or it's not in existence, it's not found. When a prefix arrives after validation and verification by the validator, you can say to the server and validator that this prefix indeed does belong to the AfriNIC member who claims to own it, so it is valid. So that's the strategy we're looking at with RPKI, sorry. So here's a number, some figures. Over 100,000 objects have been created by we've got over 70% of our members using it. You've got the address that I'm circling on the screen, IRR@afrinic.net. For those of you who are interested in the creation or deployment of these routing policies. Regarding RPKI, as I said, it's based on the validation of certificates, and the idea is to tie it to prefix certificates, and to do so, you will need to work with AfriNIC. You need to get a BPKI that is delivered by AfriNIC. So once you've got this certificate, you can use it to sign or stamp your routes, so to speak. We've got over 3,000 routes that have this certification. And all these information can be used or accessed through the member space on AfriNIC. That's where you go to create the certificate through AfriNIC. We've also got the inversed DNS system. When you've got a messaging server, you've got ways to check that it comes from a genuine server. And that's where the reverse DNS server is helpful. Beyond this service, we also have a delegation described as lame. So you've got domain names that respond that were not official, and they're answering requests, and that was a problem. So there's additional information on that because there were a number of lame or unofficial responses. You'll find more information about it on the lame part page on AfriNIC page. The DNSSEC is also an extension that is enabled by AfriNIC, which enables you to sign with a DNSSEC, so DNS security signature within AfriNIC. It means that you can be sure that the information you send from a given point are trackable, and it's a way to avoid denial of service. We're offering this service to our members, and we would like to invite our members to reach out to AfriNIC to benefit from this additional verification and security system. Beyond these services which enable us to secure routing in Africa and the RPKI, we've also got the development of linked to capacity building using IPv6 and the deployment of routing objects developed by AfriNIC, but also the creation of the signature at the ROA creation point. We're offering this information and the training. So contact dio@afrinic.net to have access to the training. And we've got an e-learning academy. We've got learningafrinic.net for training, where you can find access to all the training, free training program that we offer to our community. So beyond the capacity building on competency, we also work on deployment. We support deployment. This initiative was supported by AfriNIC to support the deployment and development of internet in Africa. And we've focused on governance. We offer training and help community members to learn how to create routing objects, creating ROAs. Next year, we're thinking of organizing a workshop, maybe before Ocean or maybe during Ocean, where we train you to manipulate these AfriNIC tools. We're studying the project to see if it could be feasible. We could open that to members, but also to the wider public. Last but not least, commitment is important. Engaging with the communities that are not yet members. There are programs that we put at the disposal of our communities. We're encouraging women in particular to take an interest in internet, but also people with limited mobility. And we're working with AfriNIC. It's one of the flagship programs of AfriNIC. There's been a lot of participation, and we've been involved in meetings, yearly meetings at the least, where AfriNIC is meeting a member of the community to talk about challenges and opportunities. And I think I'm going to conclude here. Thank you. I hope that it was informative.
Thank you, Brice. I think that's a lot of information, different bits of information. And I know that there might be many questions. Those joining us online could maybe type their questions in the chat. We're going to ask our second participant to give his presentation, Yazid, for ICANN. And after his presentation on DNSSEC, we will then move to the Q&A session. So actually, there might be another presentation afterwards, so we might try and keep to time a bit better. So you've got the floor, Yazid. Thank you very much, Serge. Thank you to Brice for his introduction, his presentation. Here we're going to talk about validation. But it's not the same validation, I think. The idea is the same. But you'll see that here we've got different elements that need to be interconnected so that we can strengthen the security. Just like in the local server, sometimes we had to strengthen certain bits, and then we get told that is there someone who's using the server or not, and we need to add firewalls and so on and so forth. So here we're going to talk about DNSSEC validation. And similar to what Brice did, I'm going to give you an introduction to ICANN. I've not got any slides for that, but ICANN is the Internet Corporation for Assignment of Numbers. It's a corporation based in LA and has the aim to work to coordinate the management of unique identifiers, IP addresses, domain names, port numbers. For those who are system administrators, then they'll know what I'm talking about. So we use the YANA function. We allocate these identifiers at regional levels, and then these different regional organizations have to manage all the different aspects and stakeholders for their region. We also coordinate policies that allow for the management of these resources. So that's basically what we do. I manage technical engagement for Africa and the Middle East. So to be quite simple, technical engagement is how to accompany, support the different operators, different technical stakeholders, regulators, ministries, universities, and help them to better understand the management standards, the implementation of these standards, operational aspects of all of this, and DNS. But we can't talk about DNS without talking about IP and routing and all these different things. But this is at the heart of everything we do. So here we talk about configuration. And in the case of certain stakeholders, I might hand over to AfriNIC to manage something for the IP address or routing if we can't deal with it. So as I was saying, today I'm going to talk to you about validation on the DNS level. So DNS is an acronym for Domain Name System. And to put it simply, I like coming back to telephone systems and telephone networks. It's the one that we're the most familiar with, that we've used the most, I'd say. When you're in a telephone network, like cable ones we used to have, or wireless these days, to contact someone, you need their phone number. So when you pick up the phone, you have to dial in a phone number to be able to reach the other person. And so they're identified by their number. So on TCP/IP networks like the internet, this number is an IP address. So each laptop, each server, each resource is identified by an IP address. And as the network expands, just like with a telephone network, if you've got several contacts, it becomes harder. If you've got 10, 20, 50, maybe you can't remember all of them. You know, you have a list, or a contact list. So you've got a name and a number next to it. And so we had to find a mechanism. We remember names, but we rarely remember numbers as well as humans. So we had to find a system that translates the names that we have to identify resources and objects and the actual address that really are the ones that identify the person. And so that's how we created DNS. So this is what emerged at the start of ARPANET. So we started by using the DNS. And this system became a critical resource for today's internet, because if you have bandwidth, but you don't have the system that translates between the two, you'll never be able to find the IP address. And if someone kept deleting your list of contacts and you wanted to call someone, you'd realize you couldn't do it because you'd have the name of the person you want to contact, but not their phone number. So there are people, just like with any other technology, there are people who understood how the system works and have understood that they can use cracks in the system to obtain things that may not fit in with the legal constraints. So this is people who abuse the system. So there's people who will trick the users and redirects them to another system or another site or a website. I think that the ministry has touched upon this, but they use different techniques. They clone websites and they make you believe that you're on the bank's website or the place where you think you're supposed to be, where you're inputting payment details and you trust the system and you do what you're there to do. You then get your data stolen because you were in the wrong place. So we then redirect users, they then redirect users to the wrong destination. And that's because this system has a certain level of vulnerability. Some people understand how it works and they reap the benefits that they can from the different issues. So that's why we want to make sure that with routing, you go to the right place. So here we're going to talk about DNS validation. DNSSEC is a protocol, a framework maybe, that focuses on asymmetrical cryptography. We use different keys, public and private. So you've got a private key that remains private and allows us to put in signatures on the DNS resources. So anytime someone comes and asks for a DNS resource, if there's a signature, then the signature is also added. And it means that the person using it, the resolver, that's the person in charge in the network who works with the ISP sometimes. And you've got other resolvers. 4.8, 4.9, 4.1, and the ISPs, be it MTN or Congo Telecom, I can't choose for you which provider you use, but each of these operators will have its own resolver. It's the same if you work in a business. You can choose to have your own resolvers, even at home. Generally, you have resolvers that may be in place. So these resolvers will then interrogate the servers. So if I Google www.facebook.com, I could check the IP address for the web. Or if I want ozn.cg, I check ozn.cg servers. So that's what a recursive resolver is, and they go interrogate a domain. And then they see, okay, I need a signature also. And how do I control the signature? So that's validation. So to run this validation, the domain must be pre-assigned. If it's not being assigned, it won't work. I don't know if you've ever noticed on your banknotes, people try and also print fake banknotes and counterfeits. If you go to the shops, what does the shopkeep do? They take the note and they scan it in a machine that checks whether or not they're original or counterfeit. You've got these different lights, and it's a mechanism here that's quite discrete that was added to the note so that we could identify and differentiate originals and counterfeits. So that is what the system does. It tells you whether it's an authentic original operator or a fake one. So you've got the validation DNSSEC that is done by the resolver. And that is generally hosted with the ISP. But the idea is exactly the same. Every time we check every DNS answer, and we do a check using different processes, mathematics. I won't give you a detailed overview, but the resolver uses these different options to see if the hashes correspond and such. So careful, there are two operations. So you need to sign the domain and activate DNSSEC validation on your recursive resolvers. He's a police officer who's going to check your ID at the entrance. And for ISPs, internet service providers, or mobile service or operators, what's their role in this whole in safe internet space? Well, their role is to activate this validation on the recursive resolvers, so that anytime we interrogate the system, anytime there's a DNS inquiry, it goes to retrieve it and runs the validation if it matches up. So the more we have signed domains, the more we can run validations. But you also need to have a resolver that has been configured to run the validation process. And let's see how in Central Africa, the level of validation is evolving. Before going into that, what do you need to enable DNSSEC validation? Well, either you run your own DNS recursive resolver in your company, your business, or as an operator, or you're using an external recursive resolver, someone else's. So you could then retransfer everything to another resolver. That's just down to different configuration choices. But if you have your own recursive resolvers, you have to connect, then you have to configure all of it and activate that kind of validation, put in place this little police officer who's going to do the check. But if you don't have a recursive resolver, then best practice is to ensure that the resolver or resolvers that you use do actually have DNSSEC validation in place. So you've got 888.999. These obviously run validation. They've been doing so for several years now. There's quite a few operators who run these in the world. In Africa too, they run DNSSEC validation. So we've heard certain remarks on the validation process and these different operations. The community generally tells us that it works for other people who've activated it. Some people say, no, it doesn't work. I don't care about validation. But people who have activated it and for whom it's worked for years, see very positive results. For those interested, if you want to see the different stats in different countries per network, you can click on the link that's on the screen there. And it's AfriNIC Labs. So it's the equivalent of AfriNIC for the Asia Pacific region. They have a lab in which they do a lot of measurements around the internet for the number of IPv6 addresses and what people use and such. So you can check it out on the link there. I think it's about 35% globally in the world. So when it comes to Central Africa, at the moment, we're around 40%, I'd say. So that's the average validation rate, 31%, I think. And in 2020, 2021 for Middle Africa, we moved from 15% to 40%. And that's because of work that we've done as specialists around technical engagement these past few years. We've had operators understand these issues. We support them in implementing this DNSSEC validation process. We worked with operators in Cameroon. And I think there was another operator in Central Africa. So you can see here that we've got a validation rate that is over 60%. If it's red, you're under 20%. When you're yellow, orange, you're around 25, 30%. So as we go, and as the validation rate increases, you move from red to yellow, orange to green. So you've got countries like Central African Republic, Chad, our Central African Republic is at 100%. Why is that? Well, they decided to send all their traffic via Google. So that's their choice. I think there's one or two operators in Chad who are using something similar. In Cameroon, I was there last year. They were quite low. They were only around 13%, I think. I participated with the workshop on configuration of DNSSEC validation, and afterwards they were convinced. We were quite worried, and we discussed, but after the workshop, we've really seen the difference. I think it's sometimes if one tomato's gone bad in the basket, people decide to chuck it all out. But no, you don't want to just get rid of everything. You know, if you don't want to put in place this whole validation, you don't have to get rid of the entire idea. Sometimes it's just the website that has a problem. So some people deactivate all of the DNSSEC validation just because there's one domain for which there's a problem. So during the workshop, we tested different things and proved that it worked and showed them the benefits of it, and explained that if there's something working with the competition, then we need to understand why it's not working locally for us. So they just reactivated everything, and it's next morning I was told, like, check it out, like we've reactivated it, and we kind of worked on that from there. I think there's one point where they had put things in place in 3 different places, and then they changed things, then they deactivated things and reactivated things on the other one. But at the moment, the rate is quite high. So Congo also is at 40% something. I think they've kept improving validation. Then if you have your own resolvers, but there are countries like Equatorial Guinea, Gabon, still have a lot to do to improve the situation. So that's a split by operator rather than a country. I think I met some of these last year here at Ocean. Some people answered, some people did not answer present. We've got 86%. And 55%, for example, in Congo for Congo Telecom and Airtel CG. So I'm just not going to read all these numbers out for you, but we we have tried to promote these technical aspects and help people embrace validation. Why? Because, well, all of this turns around making the internet safer and making sure people are aware of all the risks, all the different attacks that exist, all the different types of attacks. So that was just the next slide from that initial idea. So how do we, as ICANN and especially the technical engagement department do things? How can we assist you? Well, we try and give you information, virtual machines, maybe you can practice in labs. We really want people to have hands-on experience in our hands-on labs. Generally, we try and give you guidance, but we're not going to force you to do things a certain way. We give you advice and recommendations. We can work with you on your trials, on the different ways you're configuring things. But we're not going to connect your systems and do it in your place. We work with quite a few operators, and we've done so in multiple countries. I think Orange Maroc a couple months ago, we worked with them. We had 12 resolvers. Everything was working, and they seemed very happy. So then gradually, step by step. 3 years ago, in 2020, we were starting at 23% in Africa. We're at 31% now overall in Africa. And there's no other reason than continual efforts. And I think there's no reason that we can't see that number increase further in the future. But I can't do that alone. I can't stay at home and do it all remotely and alone. You know, it's only by collaborating and working together as countries and different individuals that you as countries and we as ICANN, we know we have to work hand in hand to improve the adoption of validation everywhere in Africa to improve safety for technology and the internet. Thank you very much.
Merci.
Thank you very much. Even though you owe me 4 minutes, you went over time by 4 minutes. Thank you very much for this presentation on DNSSEC. Let's now move on to the last speaker, who will talk about man-hours with a specific focus on security, looking at the BGP protocol. Jean-Baptiste, you have the floor.